Let me tell you the ecological story. When I started NEERI in 1987, the first job which was assigned to me was ecosystem modeling. We had one interesting director, then Professor Khanna, who gave me this job. So my first job was to train myself, because he was a hard taskmaster on some starting predator prey models. So there were few foxes and few rabbits, and we have them in the society also, but they were all in the forest. And I had to create a computer simulation model for that situation. So it so happens you have to first, before you write computer codes, you have to first give the verbal description of the model. So you have to verbally describe as to what happens in the ecosystem when there is a predator and prey. So there are around 5-6 foxes and 15 rabbits. So they eat the rabbits, and by the time some rabbits go, some are reproduced, and so there are birth rates, death rates and all that. One day all the foxes get very greedy and consume all the rabbits. Nothing is left. They felt very happy that day, but there was nothing for tomorrow. And it so happened one day all the foxes starved also, and neither foxes survived nor the rabbits survived. So there is a moral in this story. Now, depending on your mental inclination, you can assume whether development economics takes the role of foxes, or ecology takes the role of foxes, or rabbits, vice versa. Similar is the relationship between ecology and economy. There must be a balance, and that is what is sustainable development. I mean, for foxes to survive, there have to be some rabbits, and rabbits have to keep away from foxes. Rabbits feed on grasses, so there's an entire food web relationships. It's not very simple to correlate chlorophyll, temperature, zooplankton, phytoplankton, fishes and all that. So then I extrapolated my work to food chain. And interestingly, another interesting exercise was given to me, which is very relevant today, to develop an ecologically economic, sustainable village ecosystem model for India. It was very interesting, and you'll be surprised. A person like Professor Khanna used to visit villages. The district collector, Mr. Harnam Singh, who was there in the last thing, he also used to come with us, and we wanted the funding to be from Planning Commission. It did not materialize. But there were few interesting stories. There was forest ecosystem, there was agricultural ecosystem, forest subsystem, agricultural subsystem, energy subsystem, socio-economic systems, air, water, land, covering that, these ecosystems. And a lot of things I learned during those exercises, which were later on utilized for environmental impact assessment studies, which he got. The first such study was ONGC, where Rakesh is not there. He was also involved. And we developed various value function graphs for quantifying what is being debated today as to. Now, ultimately, any environmental impact assessment exercise is nothing but a cost-benefit analysis, irrespective of whatever we may feel and whatever kind of respect we may have for the environment. But at the same time, we all know that there are some development imperatives. We cannot avoid them. We have to wear. This jacket may have good or bad implications or impacts, but we have to wear that. Similarly is the developmental hat. We have to wear, even if it impinges on ecology. So we have to do some ecological economics cost benefit analysis. That is the way EIA should be done. Unfortunately, that is not being done, and that was amply discussed yesterday also, that CRZ finally, when it requires or demands that we should have rapid environmental impact assessment, comprehensive EIAs, etc., then why not we conduct our EIA in such a way that all those issues which are involved in CRZ are taken care of. So EIA with specific reference to ocean and estuary and marine pollution is the kind of thing which will serve the purpose of doing CRZ. Otherwise, do EIA first and then give it to for CRZ committee, then CRZ committee gives you the recommendation, then you again do EIA in the light of that. This is going into a helical loop. So if you want to really shortcut this process, this is the way. Second thing, I've always wondered why public consultation is done at the end of EIA. We should first consult the public whether they want this development or not, and this kind of impact. So we should have two kinds of public consultations. One before the EIA is undertaken. We should know what people want. We should just not go and give them, there is a laptop, whether they want it or not, I should give it to you. That kind of situation should not be there. So we must assess their needs, what they want. There should be public consultation. And with our expertise, we should be able to brief them as to what would be the environmental implications if this kind of route is followed. So there would be various development alternative routes which should be made very clear to the public. There should be stage 1 public consultation. Then this environmental impact assessment should be done with reference, with specific reference to ocean pollution, and we should get back to the public again with those details, methodological details and the result details. Now here there was a question yesterday on the Form 1. There were some views expressed. I fully agree that Form 1 is quite complicated, but there is a logic why it was done. Every activity or every item mentioned in Form 1 has an environmental impact associated with it. So it's not for nothing that it exists there. But we again have to go through the newer terms of reference is a redundancy. It's not needed. While all those terms of references, whatever few meetings I have recently attended in MOEF or here and there, those additional terms of references are already embedded in Form 1. One has to carefully go through that. Otherwise you can open the PDF file, like the PDF policy you can open. Now, so we can avoid doing that, going through that lengthy TUR, and with the Form 1 would suffice for quantification. Since I insisted on doing cost-benefit analysis in ecological economics terms, Form 1 would be helpful. Now there was another issue raised by our former director, Dr. Devota, that was carrying capacity. Now the present day indicator for carrying capacity is ecological footprinting. It is nothing but 1 by carrying capacity. So we can use ecological footprinting methodology and quantify Form 1 such that it gives us the costs and benefits, and compare it against the tangible economic benefits for which we are taking the development routes. That should be the right EIA methodology. All said and done, it is easier to speak here in such forums, very difficult to get things implemented. Now I will come back to my slides. The third thing which I was, because I had a difficult night yesterday because I have to decide as to what I would speak. Already whatever slides I have here have already been spoken about. Very few people realize this importance, pardon me for that, that environmental engineering just pertains to some portions of chemical engineering or civil engineering or chemistry. Many people actually, many of the environmental management plans derive, you hire so many chemists and that will solve your environmental management problem. That's not so. If you really look into the details of ecosystem and how the environment works, you will find out ecosystem almost works like an integrated circuit, electronic circuit. And whatever references I had reviewed in way back in 1987, most of the people who had worked in this area were either theoretical physicists or electrical engineer, control theory. So it's the control theory which applies mostly in ecosystem regulation. And when we try to quantify, yesterday there was a very good presentation from Professor Ramchandran on ecosystem values and services. At the moment that overlooks these connections, but unless until we do that, we will not get anywhere. And in ecology, it's not the absolute magnitude which is important. This plastic component may be larger than many of the smaller components inside the IC circuitry, but that inside thin fellow transistor working inside may be much more important than this larger value. So you have zooplankton here, phytoplankton, so many fishes may not work. One fuse wire in this room is enough to shut the power down. So we have to recognize the importance of different species or bioindicators in the nature. Actually, ideally, the EIA methodology should be just dependent on some bioindicators or eco-indicators. So if there are no fishes somewhere, that means there is an ecological problem, and then we should try to go back. Last year we had a similar workshop here, and some slides I have just lifted from there. This is the kind of problem you face in the ocean ecosystem. You have industrial waste being dumped, nuclear waste, oil pollution, household waste, pesticides through agricultural runoffs, oil spills, and various sewer and sewerage discharges. Then there is oil pollution, marine debris, toxic materials, ocean dumping and mining, tanker spills, runoff from land and industrial waste. We have already had enough discussion on sewage disposal. Then you see the way, we are contaminating. It's just one slide, but you can find out every day how many times this kind of situation we must make encountering. This is that food chain effect. Now when you have food chain effect, unless until you study things like bioconcentration, bioaccumulation, biomagnification and all that, we will not be doing justice to the quantification and environmental impact assessment which is dependent on that. Small species at the bottom of the food chain, such as planktons in the ocean, absorb the chemicals as they feed. The chemicals accumulate in the organisms and become much more concentrated in their bodies than in the surrounding water or soil. These organisms are eaten by small animals and the concentration rises again. These animals are in turn eaten by larger animals, and this leads to even further increased chemical load in them, sometimes even million times higher. It has already been quantified in various references. Polar bears, for example, which feed on seals, can have contamination level of a billion times higher than that is present in the environment. So there are some earlier international studies already done with respect to oil pollution, oil discharges, oil spills. And when there is an oil spill, spreading immediately takes place. The gaseous and liquid components evaporate. Some get dissolved in water and when oxidized. Some undergo bacterial changes and eventually sink to the bottom, thereby risking the benthic fauna also. Oil kills plants and animals in estuarine zones, settles on the beaches and kills organisms that live there, settles on ocean. It's almost like our cholesterol problem in body. Actually, ecosystem health assessment is like human health assessment. The kind of problems we also are prescribed that we should not eat oil, butter and all. Similar choking is there in ecosystem due to oil, but it is the energy driving substance also, as Dr. Mohanty was yesterday pointing out. We want energy, we cannot avoid oil. Pollution is a current cost and a future threat. It is an environmental tragedy. We have 17,000 drilling platforms in the ocean and 1,000 more are under consideration. Interaction of radiation, humidity and CO2 at land, air, water and water, air interfaces. Very difficult to quantify, and then ultimately we have to quantify the human health risk assessment. We have to do human health risk assessment. Oil exploration is going to be more risky and challenging venture. Oil prices also have various ecological, economic implications, and they have some interesting features which sometime later on I will speak on. See the kind of coastal activities we have presently going on and the way we are trying to intensify. Actually, organizationally we are doing some third-degree experiment here, so it would be relevant to you in future. But I will show you some slides which quantify the ecological footprint. Already that work is internationally on the ecological footprinting of certain ports. So this is the way we are polluting our oceans. There are coastal zone regulations. I think we had enough discussion, so I will skip these slides. There are some positive features with the present CRZ policy. It widens the definition of CRZ to include the land area from high tide line to 5 meter. And then it also includes for the first time water area up to 12 nautical miles in the sea. Now, the main change in the scope of regulation has been to expand the CRZ to include territorial waters as a protected zone. These are some new features of this CRZ, not very attractive, but still. Concept of hazard line has been introduced, but the crux of the problem is here. We have this project involving 125 crore for delineating those zones, which are currently underway. So we have 1, 2, 3, 4 kinds of CRZs. And then special island protection. Actually, you will be surprised that the entire Gulf of Khampart and Gulf of Kutch, they come under those sensitive areas. So I don't know how we are going to deal with that. The entire Gulf of Khampart is the last few paragraphs of the CRZ notification. So then we have some exception activities and then rules. Projects of Department of Atomic Energy, they are exempted. Facilities for generating non-conventional energy sources and desalination plants, except for CRZ-1, they can be done. Greenfield Airport at Mumbai. Why that is an exception is debatable, but reconstruction and repair works of the dwelling units of fishermen, etc. there. Then I think we have already gone through this yesterday. So there are some disturbing features. Although the no development zone of 200 meters from the STL is reduced to 100 meters, the provision has been made applicable to traditional coastal communities, thereby giving the chance for increased construction on the coast and highway. So there are some conflicting points here. Disallowing special economic zones. So how we will deal with them in the Gujarat region, I don't know. There are no restrictions for expansion of housing for rural communities in CRZ-3. As a major step, there are specific provisions to benefit the fisher folk community in all the coastal areas. Time-bound, it emphasizes on time-bound clearances, enforcement measures, special provisions for specific coastal stretches. Whether that's happening or not, I really don't know. And then you have these requirements about which I have talked about. So if we have to finally take reports to EIA, then why not EIA itself should take care of CRZ? This is difficult for me to understand. Then there are some international studies. I will just show you the glimpse of that. It's our Bombay mangrove bioaccumulation. This is the food chain. It almost works like an electrical circuit, you will appreciate. And this is just a segment of that, and how difficult it is to really study ecology and quantify ecological impacts. I really don't know. Then there's the aquatic food web in ocean, health impacts. Dioxins have traveled from land to ocean, and so that's the land-water interaction between. There is some data about number of large spills which have taken place. And see, this is the ecological footprint exercise, and what kind of contributions different sectors make to environmental impact assessments. Equipment failures 21%, other unknown sources 64%. This one. You see the fishing activity, which we are trying to promote as the largest ecological footprint. So how do you deal with this ecological economic cycle? More than 90% of global trade is carried by sea. Annual sea trade is about 8 billion tons. It is estimated by 2016 to grow to 23 billion tons. And unless adequate measures are taken, the associated carbon footprint and ecological footprint is likely to grow by 300%. So this in Barcelona and Naples and all that, the kind of investments which are being made on the kind of emissions we have. But sometimes if data is not available, one has to base his ecological footprint computations on the investments which are being made in different sectors. You have shore generated power compared to, there is some comparisons. For NOx you see from ship actually this is the highest, and CO2 is highest, but other pollution is much less than other power plants. Then this is different kind of activities, the kind of fuel consumption and energy consumption which they involve. Then the kind of emissions they have. So for ships, you see, it's compared to rail and trucks. So this is how you can justify which activity or which development. This is just an example I am trying to show you. Different shipping operations. Marine technology, if we have to write environmental management plan, and how this is important, where, which sector. Ecological footprinting helps there also. Then you can write process-specific, activity-specific management plans, rather than writing some plans which are very generic. And we had an interesting, actually our CRZ must be an imitation and follow of this exercise. This was a MARPOL exercise, the International Convention for the Prevention of Pollution from Ships, the adoption 1973. In all probability, this must have been a hidden guiding force behind our CRZ implications. And some similar issues were there, and they had dealt with something called NX1, NX2 regulations, NX3 regulations, NX4 regulations, and all that. There were, like our CRZ also, they had also many amendments. The essence of MARPOL Convention was, it sets out regulations dealing with pollution from ships by oil, by noxious liquid substances, and by harmful substances carried by sea in packaged form, by sewage, garbage, prevention of air pollution from ships. And this convention remains the most important international treaty covering the prevention of pollution by ships. Other potential impacts could be impacts on biodiversity, land-based activities, and here you see another ecological footprinting exercise. Here, land-based discharges, they contribute to 44%. So this is source apportionment exercise. So ecological footprint will help in that kind of an exercise also. And you have the next one is atmospheric, it's very surprising. But anyway, all these have uncertainties and some amount of subjectivity. Atmosphere, this is the various activities near seashore. So we have a ship in search of sustainable development, a term which is very difficult to define, easier to use. Then there is a question which I would like to raise, concerns money save us in such situation. And then actually most of the problems which we are facing today, as we are in too much of hurry, hurry for developing also, hurry for polluting also. It has been left to our generation to discover that you can move heaven and earth to save 5 minutes, and then not have the faintest idea what to do with them when you have saved them. To get all there is out of living, we must employ our time wisely, never being in too much of a hurry to stop and sit late, but never losing the sense of time. That is my philosophy. I feel many people will agree. Some of our future activities which we have in great indices with respect to climate change studies, and we last time I think we made a presentation on carbon vulnerability of some Indian coastal tools. And this is the slide which I'm trying to show you, shows the kind of biorhythm ecosystem. Most of the ecological functions have some biorhythm or other. And when you disturb it, in physics terms, pollution is nothing but a damped, overly damped harmonic motion. Now to bring it back to that harmony is the challenge, and that is where our environmental management plan should be. I think with these slides I will end my talk, and I forgot to thank, I think Professor Shyam I thanked, but I will thank you once again.